with the MISSI platform. It is a good business model to follow. Aggregating customer experiments into a common platform helped reduce cost and was popular with our experimenters too, because they didn't have to develop the overall or infrastructure that would be required for like communications and power and whatnot. So it was a good verified one as well. And then would NASA accommodate our business model? I mean, when we went up front with MISSI, we really didn't know, but NASA has been very accommodating. There are certain areas that NASA, in NASA's infrastructure or whatever that isn't quite as accommodating, but nonetheless, it's a minor role. And then also the customers did embrace fully fixed price contracting. They wanted to know how much they would spend, and that's how much we charge them, right? So we take the risk on fixed price. And then protecting from orbital contamination events was and still is one of the main features of MISSI and will be of both RAC and STEF. And that's something that the PIs have really liked, because they then can control what affects the experiment on orbit. It's not thruster plumes, it's not whatever other kind of environment that might not be what they signed up for when they wanted to fly on MISSI. And then other things, the power and data, and then the COTS components, all of those verified and are being used on RAC and stuff.
Thanks, Mark. I think the second part of his question is, do I understand well that the assumptions highlighted in green have the ones that were validated and the ones striked did not verify?
Yeah, that's correct.
Yeah. And the third one, I think you might have answered it, but again, let me read that. What about the ones that are in gray, bullet point 6 and 9?
They really didn't apply to RAC and STEF, to the lunar missions. There really isn't going to be nearly as regular of a launch and cadence to the moon. So, we go every 6 months to station on MISSI, and that just won't be possible for the lunar missions. And then getting hardware back, I mean, that's just not in the cards right now for our lunar missions.
Thanks, Mark. I think he has got one more question. That is, how MISSI economic compares to Airbus Bartholomew. He says euro 350K for 3U and euro 3.5 million for 450 kg for 1 year mission.
Yeah, I think Bartolomeo and MISSI are kind of in different segments of the market. So MISSI focuses on the smaller experiments, anywhere from a square inch of a material sample up to maybe about a 4U platform of some sort of technology. Or Bartolomeo then starts at the 3 or 4U segment and moves up into the larger hardware and technologies. So we're really not a little bit of overlap, but not a lot of overlap. So we're just different segments of the market.
Thanks, Mark. This one comes from Alan. The question is, just let me scroll up. Yeah, why we need a new temperature logger? Yeah. This question is for Heath.
Hi, thanks. And thanks, Alan, for the question on this. This temperature logger was designed to help with mission assurance, to be able to track with our samples specifically what the environment was like during different operational phases of the flight itself. The compact design, the small size of it, allows for this logger to be integrated within different hardware profiles, and especially those the rhodium science chambers that we feature with a lot of projects. A key advance with this logger is also the capability to maintain function and active logging in freezing conditions. And that's something that was not currently available. And having these type of loggers already certified and ready to support commercial space projects, and especially those that we do at Rhodium, really provides us a level of advanced mission assurance, quality assurance that a lot of our customers, clients, and especially those that are funding the project appreciate that level of quality care that we provide to those projects. So thank you for that question. And there's a lot more detail about the loggers within that 20-minute presentation as well.
Thanks, Heath. I have a question for you. What is, you have mentioned 0.2 degrees is the resolution. What is the update rate, and whether it is whether the device is can be the data can be downlinkable or can be or it is stored?
That's a great question. So the data is stored. It does not actively transmit, which also then helps with some of the safety certifications with the hardware. So it is retrievable after flight. The resolution of sampling is determined by the experiment itself. We pre-program the logger to select at a selected rate. And so we can go down to seconds, up to minutes, up to hours, whatever the experiment needs, so that you can capture the data sets that you need. What's interesting is within the temperature logger, we actually have two different redundant systems. So we can program one for a fine resolution and then the other one for a longer scale sampling cycle, so that you get different profiles over the full length of the mission.
Thanks, Heath. One more question from me. That is, what is the dynamic range of the temperature logger? Or what range it can operate?
Range is -40 degrees up to +85.
Okay, thank you.
And we're right now looking to advance that range in a future version. So look forward to seeing that one.
Okay, thank you so much. And I think that would be interesting, because for Artemis missions, where the range has to be extended for a lot of options, means a lot of other benefits.
Absolutely agree.
The next question is from Margaret Hitt. This is for Ethan and Derek. What challenges did you come across when creating the Nano Lab? And the second question is, what inspired you guys to focus on improving agriculture?
So I would say the largest challenge that we really faced was creating something robust while also meeting the criteria of making a Nano Lab that's really customizable and accessible to everything. Because when you start making parts of labs and pieces of technology customizable and removable quickly, it becomes a little bit finicky with your design and what will actually work, especially when you're in the high pressure situation of sending something to space and you have to deal with the vibrations on the way up and all these other factors. So I would say that's definitely one of the main issues that we ran into. And for what inspired us, we were lucky enough to work in the NASA Hunch program for the past 10 months with nanoracks and really get to talk to a bunch of scientists and engineers and figure out some of the biggest problems going on right now and what we really need to look forward to with space exploration. And it's something that really grabbed our interest and we thought we could make a difference in.
Thanks, Ethan. The next question is from Uma. What is the footprint and operational life of the logger? This is for Heath.
The footprint is about 4 inches by about 1.5 inches and 1.5 inches. So it's a small, compact device that has an operational life dependent upon the sampling rate. The battery is good for about 2 to 3 months with about a 3 to 5 minute sampling rate. And so that can be adjusted, like we said, based upon the full flight dynamics.
Thanks, Heath. The next question is from Alan. This question is to Ethan. What is the difference your system versus Veggie?
So I would say the main difference with our system compared to Veggie is that it's entirely closed and it's autonomous for 30 days. Instead of using like a clay substrate like Veggie uses and like the aeroponic systems that they tend to use in Veggie, our system uses an agar gel substrate that we can tailor specifically to different plants. So we can tailor the exact nutrients, the exact water content of our substrates so that it will work for 30 days from either a seedling or from a seed. And then whereas Veggie, it's a little bit more, you have to pay attention to it. And we wanted to take some stress off of astronauts and also allow people on Earth to create systems with agar gel and send them up and be able to have these plants survive a little bit more than Veggie.
Thanks, Ethan. This question is from Susheshna Patil. This is again for Ethan and his team. Are you so far at a prototype stage, or have you tried some plants And if you have so, which ones?
So we finished the prototype stage about 2 months ago. So we've had 2 tests put in. Our first test, we used rapid cycling Brassica rapa, which is a genetically engineered and modified plant from Wisconsin Fast Plants, which is typically an educational based plant creator, I guess you would call them. And that was just to make sure that our system functioned. And then we moved forward towards something after we saw some success in that, something more usable like red romaine lettuce. And once again, we tailored the agar gel substrate to that, and it worked out wonderfully as well. But those are the 2 plants that we have tried.
Ethan, I want to just follow up with that. Do you control the photosynthesis process, or you just you set your parameters and let go?
So depending on the plant, we've done some testing before we set up a 1-month trial, those last 2 months that I was talking about. And we received data from the sensors that are in the Nano lab in order to figure out the parameters. So like you said, we put in the parameters for the specific plant, and then we let it run for 30 days, 1 month, and it will automatically correct itself. If it senses it's too hot, then the fans will start to kick on and different things like that in order to ensure the environment is exactly how the plants would like it to grow.
Thanks, Ethan. This question from Jim to Ethan again. Have you and your partner seen commercial interest for your Nano labs?
So far it's been purely educational and research based. We've been working in an internship program in high school, and we were lucky enough to actually meet with Mike Lewis, the Chief Innovation Officer with NanoRacks, and actually get his opinion on some of our designs. But so far, no real commercial interest, and more of we're in the development stage before we get to an actual final product.
Thanks, Ethan. Again, this question is from Alan. I suppose he would like to know what is Raspberry Pi, and I would like to add why did you use Raspberry Pi instead of Arduino?
So a Raspberry Pi is a small single board computer, and this was the main reason why we chose it is because it's small. We have very hard space restraints for our project, and the Raspberry Pi fits extremely well into our project. And for the Raspberry Pi over the Arduino, we found that we are a lot more capable of running Python over a variant of C++, which Arduino uses. So Python and the Raspberry Pi was a little more accommodating for our project.
Thanks, Ethan. This question is from Liam Kennedy, again for the Ethan's group. First, he says, congratulations on creating the agricultural nano lab, and it looks amazing. And the question is, what are the plans for launching the lab? He says that he might have missed it, but again, you might have hinted at that, but again, please continue.
So once again, we're still very much in the prototyping phase, and we just created our first final prototyping stage, and we're just starting to get some real data over the past 2 months. And in part of the NASA Hunch program, there's no real right now plans to send this to the ISS. It's purely developmental. What can we learn from it? And if we can make a final product from this that will get eventually sent and tested on a 0G flight and then maybe sent to the ISS, that would be amazing. But as of right now, there's no plans for that.
Thanks, Ethan. And also for the participants and attendees, could you please explain what the Hunch program is so that people are aware of the program and your experiences with Hunch?
So the NASA Hunch program is a program, it's high school students united with NASA to create hardware. And it's where you create a prototype based off NASA's parameters with another company such as NanoRacks, which we've been working with. And you get the entire year after given a problem and you get to solve it. So you get to go in the beginning of your senior year in high school and talk to a bunch of different engineers about problems going on and really pick and choose what you would like to research. So we chose the Agricultural Nano Lab, and we had the ability for the past year to focus on that and really develop something that is an amazing product.
Thanks, Ethan. This question is for Heath, is a question from Uma. Is the humidity logging also integrated in the current configuration?
Yes, it is. The humidity logging is available and is currently configured within this within the device right now as it stands. For more information on this, and I had my email address down there, heath@rhodiumscientific.com. I know there's some more questions that are coming through, but please feel free to reach out and we can give you full test profiles and we can show you how the device operated specifically for hopefully integrating into your projects.
Thanks, Heath. The next question is for Ethan's group from Uma. She congratulates your work, nice work. And again, the question, she has a question, what sensors are integrated in your Nano lab?
As of right now, we have temperature sensors, humidity sensors, luminosity sensors, CO2 sensors, and that's about it for right now. In the future, we would like to add a handheld photosynthetic. It's a testing device. It's called the Microspec Q, and it really tells you about the composition of the leaf in the plant. But we're high school students, and we just graduated, and it's a couple $1,000s. So we didn't really have the access to that to actually integrate it into our prototype. But that's definitely something we'd love to add in the future.
Thanks, Ethan. This question is from Alan. Question to Dimitri. The difference FOMS phase 1 and phase 2.
Hello. The phase 1 system was MSG system that produced the first optical fiber on the International Space Station. These fibers are roughly $1 to $10 million per kilogram, very high value manufacturing items. We were able to generate 7-figure commercial revenue from this development. Phase 2 system that we have tested last year on ISS was express facility that we controlled ourselves. It is a modular facility where we can build payloads and exchange them on orbit and have dedicated missions. The one that we are launching right now, preparing for launch, a 3rd generation system. This is the system where we have fully modular design without open architecture, where astronauts just fill the stock material into the manufacturing system and then pull out the resulting fiber from the system when it's done running. So that's the 3 generations. Thank you for your question.
Thank you, Dimitri. Before going to Lisa's question, let me ask a question to Tony. Tony, in the thermoelectric generators, have you fabricated a working device in your lab?
Hi. Yes, we have developed a screen printable thermoelectric generator on flexible substrate in our lab, and we are trying to work with the Marshall NASA Center for powering small sensors using that flexible thermoelectric generators.
What type of sintering you are using? What is the process there?
At this point, we are using conventional sintering, and we are experimenting with both photonic sintering and laser sintering that will help us to make them faster.
What is the conversion efficiencies that you have seen with the nano material?
Still, the conversion efficiency is still very low. It's like 4 to 5% is the maximum we could get with our bismuth telluride based systems, and around room temperature to 100 degrees Celsius.
Okay, thank you. Let me go back to a question from Lisa. This is for Ethan. Will the growth chambers you designed be suitable for longer space missions? And she has another question, but let me ask that later. The first question is, will the growth chambers you designed be suitable for longer space missions?
So as of right now, we have it set in our variables in the code of the entire system for 30 days, and that's how long it will run for. And that's how long we found the agar gel can actually stretch on for without drying out and killing the plant. So at that point, it needs to be studied or it needs to be transplanted into a different medium. So as of right now, it can't pass 30 days because of our substrate that we're growing our plants in, and that is in our growth chamber. But in the future, we would love to explore other substrates like veggie, maybe a clay packaging system, even though that's a little bit harder to do because now you need an active water system. But something like that would be able to stretch on past 30 days. But with our current configuration, it cannot.
Thanks, Ethan. The second part of that question from Lisa is, they can be used for 1 month of growing period, as you have mentioned. Can they be used again for another month?
Yes. So as long as agar gel is stored properly in a growth chamber, you can keep it like a petri dish. So petri dishes will last for months at a time. And as long as they're stored properly, sterilely in an environment where no bacteria is growing on them. So if you wanted to, you could send up a growth chamber full of agar gel. As long as it's stored properly, you can start a new experiment right there in the ISS for generational studies if you wanted to.
Thanks. I think there's a question from Liam again to NanoLab team. Can you share what it has been working on this project, particularly the mentoring, and anything you want to share about working with Hunch?
The mentoring's been awesome. We've been able to work with a bunch of doctors and scientists and engineers from NASA. We were mentored specifically by Dr. Gold and Glenn Johnson, and we got to sit down and talk to them a lot about our designs. And they really helped guide us through the engineering and design process of a prototype from start to finish, which is not necessarily something kids our age get to do. And one of the things that we talked about while we were being mentored by them is the fact that we have this opportunity and this amazing opportunity. And we wanted to make the Nano Lab something so cost effective that kids across the country could be able to, in their science class, send up a growth chamber and actually do experiments on the ISS because of how amazing it was for us and how much it got us into STEM. So that was amazing to talk and learn from mentors that really care about STEM.
Thank you. The next question is again for Ethan again from Kajan. In terms of nutrition, I'm not sure that plants grown in space will have higher level of vitamin D, and Earth has some extra variations that changes our nutrition values. Would that be great to map this out and compare?
So we're not quite sure about the levels of vitamin D. Obviously, for a plant using only artificial light to grow, there will be differences between that and the well-rounded wavelengths that plants will see on Earth with the natural sunlight. So that might be one of the things that researchers can find with our project.
Thanks, Ethan. This question is to Mark from Alan. Are all your lunar missions CLPS program?
The RAC mission is Eclipse 19D mission. The STEF first mission will be a direct purchase from, we believe that'll be from Intuitive Machines. So we will directly purchase from a provider for launch services and landing services on the moon.
Thanks, Mark. Mark, I have a question for you. When do you advertise, or when do you, about the missions, the upcoming missions? How do the people will come to know? Do they have to follow you, your website, or is there a flyer or announcement that goes off after to all the interested organizations and or the research groups?
For the MISSI missions, it's every 6 months. So it's really on our website. So anytime anybody wants to fly, we usually have a mission that's pretty close by that we could integrate them to. For the lunar missions, we haven't really been advertising those substantially yet, but we do plan to. So we will be engaged with the lunar science and the lunar technology demonstration markets for regular updates about when our RAC and STEF missions will be.
Thanks, Mark. This question is from Ben to Dimitri. Did you have any issues with fiber degradation after it was produced and before it came back to Earth?
Hi, Ben. This is a very good question. In our first mission, the fibers that we produced on ISS had some degradation on their way back from ISS. In a second generation system, we had purged, sealed unit that traveled up and down without compromising the containment integrity. So in second generation of the system, we were able to minimize the degradation of our samples. And in third generation, we have advanced approach that is similar to our second generation system that will minimize or eliminate the environmental sensitivity effects of the fiber produced in space when it is returned for the use back to Earth. Thank you.
Comment on optical degradation.
Mostly the degradation is coming from the surface of the fiber, where when attacked by water vapor, the fiber loses mechanical strength. Fluoride fibers react with water and form zirconium oxide crystals that serve as centers of breaking on the surface of the fiber. So mechanical degradation is the key, but optics stays relatively intact.
Thanks, Dimitri. This question is from Marufa to Mark. What location do you choose for your research on the moon and why? Have you done any in situ resource analysis?
That's a great question. Interesting. So actually, we follow the market. We follow our customers' lead. So where our customers want to go and do the research on the moon is where we tend to target our missions. So it's really customer and market driven.
Thanks, Mark. This question is from Alan to Tony. Can you project a micro G test program?
We haven't tested micro G for thermoelectrics yet, but at this point, we are scheduled to test the radiation effects on thermoelectric material using the MERITS program and see how that affects the thermoelectric performance.
Thanks, Tony. This question is from Bill to Ethan and the team. Do you have any idea about what the best plant source for protein that could be grown with your system?
So that's a very interesting question, and it's something that we would love to research in the future because we don't really have an answer for it there. It's generally one of those things where we were working with produce and vegetables, kind of copying veggie and the things that we've seen before, but also it's researching something like legumes and things that are high in protein and finding a way to start them off as seedlings in our system would be amazing. And that's definitely something that we would like to research in the future.
Thanks, Ethan. Question is from Ben to Dimitri. Did you test signal loss in your fiber? How did that compare to fibers down on Earth?
The insertion loss for the fibers that we produced so far on the station and on Earth were limited by the quality of the preforms that we received from our vendors. The loss was comparable on the ground and in space. What we have seen, where we have seen the difference, is scattering. Scattering is reduced for the fibers produced on International Space Station in microgravity compared to ground samples.
Thanks, Dimitri. I think we have come to the questions. There are no more questions, but I would like to, just because we have 3 minutes, if each of you could discuss about it, the benefits of your program and what are your future plans, if possible. I start with Tony.
Hi. So currently we are working with NASA Marshall on developing a 3D printed energy harvesting device using thermoelectric generators because they are highly reliable and it doesn't involve any moving parts. So it is highly reliable for longer space missions and where the solar cells or solar energy is difficult to harvest. That is the current goal, and that's where we are working at this point. And our future missions We are involved in using extrusion printing of thermoelectric generators so we can harvest or change the radioisotope thermoelectric generators for more robust and lightweight thermoelectric energy harvesting applications.
Thanks, Tony. Dimitri.
The interesting part that we see with our development is that we are trying to graduate from nanoracks or space tank or 1 liter, 1 watt type of experiments towards manufacturing platforms that can do hundreds of liters, hundreds of watts manufacturing capabilities. And that's probably the most interesting part about our development. We are open to work with people who are interested in our platform. This is open architecture. I think it provides an exciting opportunity in terms of environmental controls and process controls. So I think we would like to invite partners to this exciting opportunity that we have developed on International Space Station for manufacturing. Thank you.
Dimitri.
Yes, so for the Rhodium Science temp log, we are going to continue to use and operate the temp log within the Rhodium Science chambers to support our clients and customers. But we're also going to be able to provide this commercially to other hardware developers, other research teams that would need temperature, humidity logging during their missions. And we're also providing this terrestrially as well. So for controls, for ground controls, and for developing the projects during the initial testing phases, the Rhodium Science temp log will be available at all times.
Ethan?
We would love to see our project in the future get developed into a final product from its prototype, and then eventually see itself in a commercial setting where we can actually start testing on the ISS and maybe taking it onto the 0G flights and making sure everything's working. And that would be amazing to see in the future. So,
Mark? Oh, Ethan, a quick question. There is a question from Lisa again. Have you harvested lettuce you grew from your prototype, and how did they taste like, and what 3D printing materials do you use to work on your prototype?
So luckily, lettuce is one of the things that reaches maturity in around 30 days. So after that, we actually did get to eat lettuce, although the leaves were only about 3 inches in height. But it tasted like lettuce, and it was awesome to see that it actually worked. And as for 3D printing capabilities, we would love to print with Ultim in the future, but the printers that we have access to don't have the heat bed. The bed and the printing nozzle can't heat up to a high enough temperature to print with that material. So for the prototyping phase, we're just using ABS, but that's obviously not ideal. We would love to change that in the future.
Thanks, Ethan. The last comment from Mark.
So for the benefit of space testing as a service is that it's commercial. So people and organizations who have not had access before can now come directly to AlphaSpace and purchase a test program in low Earth orbit or on the lunar surface. You no longer have to be selected by NASA to do this. You can come to AlphaSpace and purchase it. And for the future, we plan to have these platforms in many different orbits, on ISS, on the commercial space stations, and MEO and GEO, and certainly on the lunar surface and cislunar. So for us, that's the future of space testing.
Thanks, Mark. And I think this was really a good session, and I would like to give the controls to Alan and Jim for their final comments and observations.
Excellent. Excellent, Prasad. Thank you so much. And, Ethan, you guys, I wish somebody had asked you guys a question. I mean, geez, you didn't talk at all during this whole thing. No, it was really great. Thank you so much. Oh, and by the way, if you need a temperature sensor, there's this other guy named Heath. He's sitting right there. You might be might be able to work with him. But no, thank you very much to all of you. This is really cool. This is a lot of fun stuff to hear about. And Prasad, thanks very much for running that session for us. We appreciate it. So, hey, that does it for today. Thank you to everybody for participating. I do want to make sure you come back tomorrow. Tomorrow is our posters day. We've got a lot of great posters running from 9 a.m. to noon Eastern time tomorrow. Things like space weather, deployable structures, deep space flight effects on immunity. You know, it runs the gamut and it's really cool stuff. So join us for that. Thanks again, everybody, for coming today. And of course, thank you to all of our sponsors. The Boeing Company, this year's ISSR&D conference platinum sponsor, as they have done for many, many years. They've been a big part of making this all work, and so we thank them very much. And our other sponsors, Airbus, KBR, Leidos, Northrop Grumman, Sierra Space, Space Tango, Teledyne Brown Engineering, the Engineering and Innovative Technology Development Team at the University of Alabama, and thanks to our exhibitors, Jacobs, Oceaneering, and TechShot. With that, signing off from AAS on behalf of Alan DeLuna and myself, Jim Way, we will see you tomorrow morning at 9 o'clock. Please come by and join us for that. And take care, everybody. Have a good night.
Thank you.
Thanks all.